In this video, we're going to take a look at the changes that we make to the small sample procedures for mu1 minus mu2 when we have sigma 1 squared is not equal to sigma 2 squared. So in a previous video, we looked at what we can do when we have equal sample sizes, and in this video, we're going to take a look at what we do when we have unequal sample sizes. So when n1 does not equal our n2 value. So first, we're going to take a look at our confidence interval, so Ci. And our confidence interval is going to start off the same as it's done before, so x1 bar minus x2 bar, all that, plus or minus our t of alpha over 2. And now again, where we're going to make the same change, or similar changes to we've made in the past, to our standard deviation. So we're going to look at our new standard deviation is going to be s1 squared over n1 plus s2 squared over n2. And we're going to take the square root of that entire sum. So the square root of all that. And that's going to be our new confidence interval. Now for our hypothesis test, and we're going to make a change again to our test statistic. So we're going to say t is equal to x1 bar minus x2 bar all over our same formula for our standard deviation. So it's going to be the square root of s1 squared over n1 plus our s2 squared over n2 value. And now the biggest change that we see for equal sample size or unequal sample sizes is to our degrees of freedom for our t value. So we're going to say the degrees of freedom for t is equal to this v value, where v is equal to, we have s1 squared over n1 plus s2 squared over n2. And we're going to take that whole value and we're going to divide that by s1 squared over n1, and that value is squared, divided by our n1 minus 1, and we're going to add that to our s2 squared over n2, all that squared, divided by n2 minus 1. So it's a big change to our degrees of freedom for our t value. And if you actually walk through this formula, most of the time you're not going to actually get an integer value for our degrees of freedom. And in that case, just round to the nearest integer and look that up in your t value table to find the actual t sub alpha or t sub alpha over 2.